That was funny. So we are going to generate oh my gosh. Wait just a minute. There's no way. There's no way they're telling you to do 10 or samples. Are you kidding me? What? You want me to do that whole process 10 times? 10! Thanks for the busy work. Jeez, why, man? Am I reading this correctly? They want me to sample this population 10 different times. 10 times! The last assignment I did, we only had to do 2 samples. Are you kidding me? What is this? Dude. Oh my gosh. Oh. Ten. This is ridiculous. They want you to do 10 samples. So I'm going to just refresh myself on how to do this question by looking at this. It was probably the first question from before. Because, it was number 7, right? If it was number 7, 7 is right here. So, hey, look, it's Bad Apple. Soak it in, folks. It's Bad Apple. The original Bad Apple, not the stupid remixed one. Okay, it's not stupid. I just hate how it's overused. And nobody ever uses the original. So that's why I hate it. Here's the original. Soak it in, everybody. This is the original. That was fun. Now back to the homework. So the way I generated a sample, I did only 2 samples here. See? Number 7. Number 7. Oh my gosh. Are you kidding me? Are you kidding me? I have to go all the way to the next set of problems. Man, this is taking 5 years. Oh, found it. Number 7, generate 1 sample. Now generate another sample. So they seriously want you to generate 10 samples. Are you kidding me? 10. Where even is it? Come on, where is it? Where's the freaking problem set? simple random sample. Okay, I'm gonna go to, it was like 320, I think. Right? No, I think it was 317. Where is it? Where's the... It says simple random sample of size 25. Analogous to this, generate 10 simple random samples of size 20. 10 different samples of 20. 10 different ones. Really? Well, at least that's most of the work for the problem. I mean, not really. No, it's not. Because I have to do the mean, median, and standard deviation for every single one. Okay. So for annual salary, we always want, the only information we want is annual salary. So what we're going to do, so let me just make sure I know how to do this. Basically, this is not good. I'm going to have to look it up because I didn't save the formula. But basically, generate your sample, and then put it over here, then do all your calculations. The thing is, I think it's like rand or something like that. So if I just do rand, it should give me random numbers. And so yeah, we just want annual salary, so we're just going to put it answers. So we're just going to copy and paste annual salary, and because that's all we want to look at. Copy and paste. So here's the original data, and now what we'll do is do a bunch of samples. Ooh, geez, this is gonna be awesome. This is gonna be something right here, folks. So what we're going to do is we are going to have equals rand it will generate a random number, and what size do we want it to be? Well, first of all, we're just going to go all the way down, and it will generate your random numbers, and we're going to have to do a certain process like 10 different times. So we have now generated a bunch of random numbers. So the next step is like, watch this. You can change your generation over and over again by just doing this. So that's a very nice thing. So what we're gonna do, we've generated one random set of numbers. We want our samples. We're doing 7-1. We're doing 7-1. So we've generated size 20. So what we want, first of all, every time we're going to sort. We're going to sort that by column B. Actually, you know what? We're going to name this random. I don't even know what you name it. No, I'm not going to name it. We're just going to column B is what we're sorting it by, smallest to largest. So now that we've sorted it from smallest to largest, no, we haven't. What? What? You haven't sorted it yet. Maybe the reason is because I need to copy and paste the values or something first. I think that might be the problem. This is going to be so annoying. Okay, we're going to just do another one here. And then we're going to copy and then paste the values. And then we're going to sort. And then we're going to sort. Now it's good. Now it's good. So here's our first random sample. Now we are going to select the first how many values? 20. So basically go to cell 21 because of stuff. And we've gotten our first. We've gotten our first set of 20. So that's our first random sample. So now let's figure out a quick way of repeating the process. Now we'll do equals rand. Again, we've now generated a bunch of random numbers. Copy, paste values, and now we will sort by smallest to largest, and we have generated another random sample. Man, this is so annoying. Why do we have to? I have to do this 10 different times. Like, there's got to be a better way to do this. There's got to be a better way, but I don't know what it is because our textbook sucks. I mean, I guess I could have looked in the textbook, but there's probably not going to say the answer, so why even bother? So there, I got another random sample. Oh my gosh, he's seriously making me do this 10 times. Look at how tedious this is. Oh, yeah, good song. I'm just gonna double check to make sure I'm actually supposed to do this. Seriously, 10 simple random samples. 10. What are the odds that we got the same result twice? Oh wait, never mind. Sort from smallest. Yeah, whatever, we're just gonna do this. Only 2 more times. Only 2 more times. Only 1 more time. Nope. And that's it. Look what you made me do, textbook. Look what you made me do. That's a fun block of numbers. Hey, here's what we're gonna do. Oh my God. We're gonna do answers part 1, and answers part 2. So answers part 1, here are all the samples. So for what we want population stuffs, and then we want sample stuffs. There's going to be 11 different things that we need to calculate. Wait just a minute. This could be easy. I could just copy and paste the calculation from thing to thing, basically. So, yeah. I only need to do I only need to do 2 calculations total, one for the population and then one for one of the samples, and then I will copy and paste all of them all over so that everything is everything. So we want population. So first of all, we want mean, median, and standard deviation. Mean, median, and standard deviation. So, and we want the population, and then we want that's funny. So what is the mean of the population? So it's going to equal average of all these. We want 71 to 74, blah, blah, blah. Just double checking. Good, always good to double check. That was funny. 71 to 74.51. So yes, that's pretty much right. The median. So median of these There you go. Standard deviation. I'm going to try both and see what happens. P and S, because it's like, what difference does it even make? Hey, I got different answers. Man, I hate myself. Hey, they didn't tell us to calculate the standard error. They wanted us to calculate the standard deviation. Man, I don't even know. Like, why do they give different results? Shouldn't they be the same? What's the P population one? Why is it different? I'm just gonna use S for. I'm just gonna use the S one. The difference between these two is that this is S and this is P. We're gonna just use the S. I'm going to use P instead of S because we know this is the population, right? We know that's the whole population. We're treating it as the whole population. And we're taking samples. So we're going to use the population one instead of the sample one. We know that's the whole population, so why not use the population one? So equals average of now that should work. Boom. What's the problem? I don't care, shut up. What the heck? How come we're getting exact numbers? How are we getting exact numbers there? How are we getting exact numbers? How are we getting exact numbers? But we didn't get an exact number equals average for all of these. Like what? Why? What? How are we getting exact numbers here every time?
Also, they didn't tell you to get the sampling or the standard error. They said standard deviation.
Guess we're gonna only have one more question after this. Huh. Well, everything sucks, but yeah. I'm gonna rename that file. Should have renamed it before, but 7.1 instead. I need it to be named 7.1. Okay, so the reason why I kept getting I never got a single decimal answer is because I'm dividing it by 20 and every single one has 2 zeros in the beginning of it. So if you divide something by 2 and it's an even number, you will not get a decimal. And if you divide it by 20 and it's an even number that's more than 10, I guess, because no, more than 100, which all of them are, then you're not going to get a single decimal answer. So that makes sense. So yeah, stop. Okay. We only have one more question and then we'll be done with this project. That's funny. Number 10. Seven, 10. Oh. Yep, here it is. Oh, not here quite, but here. I don't even feel like doing this right now. That's good. So. Total income, that is the sum of first income and second income. So it is first income plus second income equals this plus this so now we got total income. So for each of the four variables, total income, monthly payment, utilities, and debt, find the sample mean. Okay, so that should be simple enough. Yeah. B. Total income, monthly payment. Utilities, debt. What is the mean of total income? Monthly payment. Utilities. Debt. Total income of 66,000. Monthly payment of $978. Utilities was $235, and debt was $4,300.
I don't know. Well, that was freaking funny. How many more parts do we have left? I just did B. It took 5 years. What are the approximate standard errors? Forgot how to do that. I have to look it up. Once. Wait, that was funny. That's fine. So, I'm, this is hilariously funny. I will be AFK for like 10 minutes. So, that's great. That's just great. That's fine. It's standard error. I forgot how to do that. Standard error. So let's go back to this and figure out how to do standard error. So I just gotta calculate the standard errors of the estimates in part B. So, and then, so yeah, I've done all this before, pretty much. Like, so now the way to do this is you do standard deviation of the sample, probably, divide by the square root of the number of the sample. So divided by the square root of the number of the sample there. So standard deviation divided by square root of the number of the sample. So this is going to be equal to so equals standard deviation dot S of total income. So standard deviation of that divided by the square root, right? It's square root of the number of the sample. How many are there? 500? 500, so that was for total income. It was the J column. Total income was the J column. The square root of 500 and square root of the number of the sample. So there. So wait, hold on. So the monthly payment, so standard deviation of those divided by the square root of 500, because that's the number of things. So there, we've done 2 of them. We're good there. I'll be back shortly. That was funny. All right. That was funny. That was funny. That was funny. That was funny.
Nice. So. Really, it's already an hour 14. Well, whatever. I'll keep going for a little bit longer. So we already have this and this done. So we'll now do it for utilities equals standard deviation of utilities and divided by squirt. That's 500 and yeah, and equals standard deviation dot s of det divided by square root of 500 and there. So and now finite population correction is required when? When is it required? Man, just let me find it, jeez. When is it required? So when 5% or less of the population is sampled, you don't need it. 5% of the population. What is n divided by n? N divided by n. So the population 500 divided by a million. So this percentage is like, well, such a tiny percentage. So standard errors, we have standard errors here of one, that, and that. I forgot what the interpretation of that is, so we might have to open another thingy. We're this close to done. I mean, what's part D? Okay. So we should be able to figure that out. So standard error, we have what that means. The standard error
means that there's a 68% chance that the estimate are off by no more than that. So yeah, that's pretty straightforward. So yes, C. There is a 68% chance that the actual values of the means are that the sample means are within one standard error of the population means. The finite population correction. Wait. Is not required because n divided by n is only point. So this would be 1%. This would be 0.01. 1%, so 0.05%, far less than and so we've finished C, I believe. We just have D left. I wonder what those emails are. Oh man. Holy crap. She graded my exam. Oh my gosh. Oh my gosh. I'm going to look at my final grade, or I'm going to look at my grade in the class, not the grade of the exam first. My grade in the class is a 95%. Bad sign. This is a bad sign. It went down from 98% or 99% to 95. That's a pretty significant drop. But let's see what the grade is. Oh my gosh, I have to look. 88%. Is there a thing? I got 88% out of 100. Okay, that's not that bad. So I finally got that graded. Wonder if there's feedback on this. I don't feel like looking at it. But yeah, I got an 88% in my exam, my first exam. That was a million years ago. So yeah, that was fine. So D. Only one thing left here. One thing. D. Is it likely that the estimate of total income is accurate to within 1,500? Yes. Or I can answer this easily. Very easily. We're so close to done. So, is it accurate to within 1,500? It says the standard error is 1,300. The standard error is 1327. So yes, it is likely that the estimate of mean total income is accurate to $1,500. So I think we're done. 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 We are done. We are done. We are done. Oh my gosh, we're done. That's it. We're done. Right? Is there anything else I'm missing? Thank goodness. I was going to be so mad if there was more than just a D here. We're done. We're done. We're done. We have done it. We have gotten all the questions for this project done. Oh my gosh, we're done. We're done. I mean, how long it'll take me to submit? I don't want to stress myself out. That was funny because I have funny.